Hi folks, welcome to this short video. I'm Dr. Nick Bierman and I'm going to be taking you through one of the practicals for one of my courses. So we're going to be doing a practical in GeoDa from the Advanced Art as a GIS Spatial Analysis and Statistics course. And so we're going to be going through practical 1 where we use GeoDa to calculate some spatial statistics. So let's go ahead and share my screen. Cool. So when you open GeoDa, you'll notice we've got a couple of windows here. We've got, oop, apologies. This is what it looks like when you get started. So you have two windows here. So you have the main bar at the top, and then you have this one that opens automatically, connect to data source. If for whatever reason that's not appeared, you can click on the folder icon and this will appear. So this is where we open a file. This is where we get started. So we're going to click on the little folder icon, and you can open a shapefile if you want. We're going to open a geo package. So here we're going to open the Greater Manchester LSOA Age IMD geo package. So you'll get that from the link in the workbook. And because it's a geo package, we can have multiple layers in the geo package. So we're going to choose which one we want to use, which is this one. And then that's loaded, and it has created a basic map for us. So this is just a preview. This is what the data looks like. This is what we're going to work with. So GeoDa is a very flexible tool. We can create a choropleth map in it if we want to. So just to give us a little bit more context, if we right click on the map here and then choose change current map type and then choose natural breaks and 5, so that's how many classes we're going to have. And it's going to say, okay, what do you want to show? So we're going to use IMD decile. So select that and choose OK. So here's a map of the deciles. Possibly natural breaks is not a great choice for deciles. So perhaps we would want something else. Anyway, you get the idea. You can see we've got the different colors here. Yeah, it's not a mapping program really, it's a stats program. So that's where we're going to focus. So it's worth saying we can open the attribute table for the data. So that's this one here. And that will give us something like this. And we can also look at a histogram. So we can choose a histogram and it says, okay, what value do you want to look at? So let's have a look at IMD decile again. And then we get a histogram. The really cool thing about GeoDa is it has linked displays or brushing. So that means if we click on any one of these windows, so click on one of the bars, let's click on the lowest bar, it will highlight the relevant bits in the attribute table and in the map as well. So these yellow areas. And it works always. So you can click on a point in the map and it will highlight it in the table and on the graph as well. Admittedly, one doesn't show up very well on the graph, but you can also click and drag and highlight an area. And then it will show up these in the table and the histogram. So in the histogram, it's the darker bars that are highlighted. So we can drag that around and see how things vary. So it's a really, really flexible tool. So let's get into the statistics, which is what we're here for. So to calculate any of these statistics, we need to tell it what its neighborhood is. And to do this, we have spatial weights is what they're called. So if we go under Tools and then Weights Manager, and we click Create, here we go. So we've got to pick a variable to store our weights information in, so our weights ID. So we'll add one. Poly underscore ID is the default, so we'll add that. And then we get to choose what sort of weights we want. So there are various different options. We're going to go for queen contiguity. So these are, if we're in a grid, it would be diagonals or up, down, left and right. And the order is how far out we go, how many rows we go. So we're just going to stick with one, which is the default. So click create, and then it creates this GAL file, the weights file. So we click save. It's asking me to override it because I've already got one, but it won't do that for you. Now it's saying it's created successfully. Cool. So then click close. So this is our weights manager, and we have some statistics about the weights here. So what it is, how many we've got, blah, blah, blah. So we can view a histogram of the weights. So it tells us the most common number of neighbours is 5. Yeah, not massively surprising. And then we can highlight that and show them on the map and so on. We've got a few areas that have only got 2 neighbours and some that have got a huge number, like 12. We can also view the connectivity map. So this is where we click on an area and it will highlight its neighbours. So as it's defined in the settings we chose. So if we zoom in a bit, if we click on this one here, we can see it's got those neighbours and so on, and we can navigate around. Some have got really big areas, some have got really small ones. Cool. Great. So let's close some of this. We can calculate our spatial autocorrelation. So this is the Moran's eye calculation we talked about. So to do that, click on space and then univariate Moran's eye up the top there. And it'll say, okay, what one do you want to calculate? We're going to use the rank because it doesn't really work very well with the decile. We're going to use the rank and click OK. This will give us our Moran's eye scatter graph. So if I make that a bit bigger, just so you can see, so we've got a Moran's eye 0.56. So there's some spatial autocorrelation here. Not a huge amount, but a reasonable enough to say yes, space is important in this data set. And again, we can use the link displayed. So if we highlight, say, a quadrant there, it will show us on the map where these are. So these are areas that are less deprived, and they're surrounded by areas that are less deprived. And we can move that around, and it will show us the different areas on the map. Cool. We can also calculate the local Moran's eye. So this is the clustering, sometimes called LISA, Local Indicators of Spatial Association. So under here we go space and then univariate local Moran's eye. And again, it says what do we want to do? We want to do the rank. And then it's saying which windows do we want? So we want the significance map and the cluster map. And we may as well get them around scatter plot as well. So this creates these 3 windows. So the Moran's scatter plot is the first one, same as the Moran's we've got already, so we can get rid of that. The interesting one is the red and blue map. So here, these are where we have statistically significant clusters. So the dark blue areas, so what they call low, low here, are areas which have a low IMD rank. So these are deprived neighborhoods, and these are surrounded by deprived neighborhoods. Then the red areas are high rank values, so these are well-off neighborhoods, less deprived if you want to put it like that, surrounded by less well-off neighborhoods. The kind of light blue and light pink are where we've got mixing, so either low, so deprived neighborhoods surrounded by well-off neighborhoods, or well-off neighborhoods surrounded by deprived neighborhoods. Those are not particularly common. It's the clustering of the same ones is much more common. And if you know Manchester at all, this map should match your kind of expectations of where the posh areas in Manchester are and where the deprived areas are. And it kind of, as an outsider, we've got deprived areas in the city centre and well-off areas on the suburbs, which is kind of what you typically expect. We can also save these results. So we can right-click and choose Save Results. And this will create these 3 new variables, Lisa I, Lisa CL, Lisa P. And then if we go back to the attribute table, those are here. So I is our Moran's eye, CL is the classification, so whether it's not significant, 1, 2, 3, 4, so on, and the probability. So I didn't actually mention the probability, and that's this green one here. So here we're saying the dark green areas, well, any of the green areas are significant, so there's a statistically significant cluster there. And then we can say, to a degree, how significant. So whether our P is 0.05, 0.01, or 0.001. How you interpret how significant this is depends a little bit on the data and your kind of philosophical approach to statistics. At the level we're working at, It's whether it's significant or not. We can go into the whys and wherefores of different levels if you want to, but it's not particularly important. The other key thing is that these white areas, there's no significant clustering there. So we can say statistically we've got clusters of well-off areas where they're red, deprived areas where they're blue, mixed areas with a light red and blue, and then everything else, there's no significant clustering there. Great. So I hope this video is useful, give you a quick demo of how GeoDa works. It's a really useful tool for spatial statistics. Do have a play, have a look at the options, and look forward to seeing you in another video. Thanks very much.